Hi everyone, in this video we talk about the human activity detection model that we implemented as a part of our Introduction to Big Data course. But before we get into the implementations, let's first have a look at why activity detection is important. As we can see from the current trend, data analysis is becoming increasingly important in the field of medical care. Activity detection can be important for the purposes of supporting the elderly for independent living. Companies like Fitbit rely almost entirely on activity detection, while companies like Apple have introduced features like fall detection in their Apple Watch products, which could be a life saving feature. For example, if a person falls and doesn't get up for a while, he's probably injured, so the watch automatically alerts the emergency services for assistance. For these reasons, we've chosen the localization data for person activity as our dataset, which we obtained from the UCI machine learning repository. For the creation of this dataset, 5 people were asked to perform a sequence of activities over 5 times, and the dataset contains over 8 attributes and 11 classes, which we'll get into in just a minute. Alright, let's have a look at the attributes in the dataset. The dataset has over 8 attributes, namely the sequence name, the tag identifier, timestamp, date, X, Y, and Z coordinates, followed by the activity it is classified into. As we can see from the notebook in the right, the sequence name is composed mainly of nominal values from A01 to E05. Over here, A denotes the name of the person being recorded, while the number denotes the recording session of that person. The tag identifier helps us identify which tag sensor information is actually being reported in the row. The timestamp tells us the time at which the recording was made, while the date gives us the date of the recording. The XYZ coordinates, as we know, are simply the XYZ coordinates of that tag. Finally, the activity label gives us which activity was actually being performed. Let's have a look at an example instance. Here, A01 is the sequence name. A is the name of the person performing the activity, while 01 is the first recording instance of that activity. The second column, the tag identifier, corresponds to the chest tag, so we know that this row reports data mainly for the chest tag. Here's the timestamp and the X, Y, and Z coordinates for the data. As we can see, this particular row has been classified into the walking activity. Next, we get into pre-processing the data. As a part of our pre-processing, we checked for missing values and removed highly correlated activities. For example, activities such as lying and lying down had an extremely similar variation in terms of their features. So we removed these activities and ended up with final 3-class labels, namely lying, walking, and sitting. Since these are the most important activities generally performed by humans, we still managed to retain over 80% of our data set. We can see the cleaning being performed in the Jupiter to the right. Next, we get into the feature extraction from our dataset. As we can see from the right, we found out the summary and visualized the dataset as follows. We found that lying, sitting, and walking comprised a major part of the dataset. To see the correlation between all the attributes, we plotted their correlations as can be seen in the notebook on the right. The observations from the plot can be seen below. We found out, looking at the upper right triangle, that the attributes like the timestamp, tag identifier, X, Y, and Z coordinates were highly correlated. And this is what drove our attribute selection to train our model. Let's have a look at the variation between each attributes activity-wise. As we can see from the box plots for the activity versus tag identifiers, the timestamp, the X, the Y, and the Z coordinates, we are able to make out how each attribute varies with activities. Thus, this gives us a good sense of which attribute to select for the purposes of training our model. Next, we dive into the train and test strategy we used for our model. After dividing the data into several ratios, we found the best split to be the 70-30 train test split for our model. For the purposes of fine-tuning our parameters, we used a 5-fold cross-validation repeated 3 times. This helped us to work with the dependent and grouped data as in the dataset below. We can see in the notebook on the right how the data was split into train and test groups. Let's have a look at the model we used to classify our data. We use the decision tree model for the purposes of binning our activities based on the given attributes into sitting, falling, and lying. As seen from the attribute correlations plotted above, we selected attributes such as the X, Y, and Z coordinates along with the timestamp and the tag identifier for the purposes of training our decision tree. As we can see from the decision tree in the notebook to the right, based simply on the Z coordinates, we are able to classify activities such as lying and walking with the accuracy of 61 and 53% respectively. Alright, let's try and evaluate our model now. We were able to achieve an accuracy of over 73% in classifying the attributes into activities. Let's analyze the performance of our decision tree. Based on attributes like the Z coordinate, we were able to classify the data to large extent. Next, it used the tag identifier attribute to be able to differentiate between activities like sitting and walking. Thirdly, the Y coordinate was used to differentiate between activities like lying and walking. Let's get into the error analysis of our decision tree. As we can see from the confusion matrix, we were able to predict correctly activities such as lying, sitting, and walking with an accuracy of about 82, 71, and 80%. However, our tree still got confused between activities such as lying and sitting about 16% of the time and walking and sitting about 12% of the time. Finally, let's summarize what we just saw. We saw how each activity varies with the attribute, mainly through the box plots of the activities and attributes. This also validated our initial ideas that activities such as lying would have a very little change in all 3 coordinates, whereas activities like walking would have no change in their chest Z coordinate, especially while the person is walking on a straight line. To improve the performance of our tree, we can further do a time series analysis of each of these attributes, which is definitely bound to increase the accuracy. Thank you for your time and patience. Have a good day.